Hi fellas, this is Chemaddcts again to the solution. Welcome back. So today in this video tutorial we'll learn about the term what is meant by structural isomers, identifying the compounds that are isomers, and the mark distribution of this question. Okay. So let's get back to the question. So the question asked explain the term structural isomers by reference to two molecules selected from the table in part A. Okay. So they asked us to explain the term structural isomers, and they also asked us to find the two molecules that are isomers. Okay, so excuse me. So first of all, let us find the structural isomers. Well, let us at first define what is meant by structural isomers. Okay, so structural isomers structural isomers are molecules structural isomers are molecules which have the same molecular formula structural isomers are molecules which have the same molecular formula but different structures but different structures. Right, so excuse me. So this is the definition. Sorry for my bad handwriting. I know that my bad I know that my handwriting is really bad. Structural, so let's get back to the question. So let us review the definition again. Structural isomers are molecules which have the same molecular formula but different structures. Okay. So it is the same molecule. It has the same molecular formula but different structures. So let us see. So this is the explanation of the term. So now let us look at the two molecules. Let us identify the two molecules. So the criteria for being structural isomer is to have they should have the same molecular formula but they have different arrangement or different structures. Okay? So let us compare with A and B. Okay? So in B there is no branching. So how we can say that if we draw the structural formula of this, let us draw the skeletal formula of this. Okay, the skeletal formula of this should be this. It is it is the straight chain. It is directly the straight chain. Okay, so it has 12 carbon. So the skeletal formula should be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So it is simply just the straight chain. Well, let us compare with A and B. So since there are only 12 carbon, it has 12 carbon. So now let us compare the molecular formula of A and B. Okay, so let us at first count the number of carbon atoms does A have. Okay, how many carbon atoms does A have? So let us count. So each corner of the straight line represents, each edge represents one carbon atom. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10. So A has 10 carbon atoms. Since there are difference between the carbon atoms between A and B, so this shouldn't be the isomer. The first requirement is to have the same molecular formula. Since they have differing number of carbon atoms, so the molecular formula of A and B shouldn't be the same. Okay, so A and B is not the molecular isomer, structural isomer. A and B shouldn't be the structural isomer. So let us move on to A and B. So let us count. Here it has 6 carbon. Carbon number is 6, 7, 8, 9, 10, 11, 12. So it has 12 carbon. Well, since it has the differing carbon with A and B, so this shouldn't be the isomer, but B and D should might be, but B and D might be or maybe are isomers. Okay, so they might be isomers. So here is one thing: though they have the same number of carbon atoms, but they might have different number of carbon atoms. So let us calculate the number of carbon atoms. Let us calculate the number of hydrogen atoms. Since they have, though B and D has same number of carbon atoms, but they might have differing number of hydrogen atoms. Okay, so here we have two hydrogen atoms, two, 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 one, two, 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 one, two, three. Let's count. 1, 2, 3, 4, 5. Up to the 10, 11. 1, 2, 3, 4, 5. 10, 21, 22, 23, 24. The molecular formula of this is C12H24. Okay, so let us check the molecular formula of this one. Let us count the number of hydrogen atoms that this compound has: 3, 20, 23, 26. So here we can see that it has two hydrogen less than this molecule. So this shouldn't be the isomer. Since it is the straight chain isomer, and since it is straight chain molecule and there is no double bond, so the so it is normal that the molecular formula of this one and this one might not be the same, because remember one thing, that the cyclic compounds, cyclic organic compounds formula matches with alkene formula. Okay, so alkene formula and cyclic compounds of cycloalkanes have the same general formula. So if we compare them to, we will see that it has the general formula HMH2N. So it does match with the general formula of alkene, but this one and this one have different general formula. I hope that you have understood. So let us compare with B and E. At first, let us find the molecular formula of E. So how many carbon atoms does this have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, it also have 12. 12 in the straight chain, and 2, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it has total number of 14 carbons. Since the since there is differing number of carbon, so B and E shouldn't be the isomer. Okay, the only thing is left is C. So let us count the number of carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 carbons, and we can see that it has a branching. It has the straight chain carbon atoms, and there is also a branching. So there is also a branching here and here. So if we compare this with A and C, we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 8 carbons in the longest chain, and in C there are 1, 2, 3, 4, 5, 6, 7, 7 carbons in the longest chain, one less than A. Okay, and that carbon is now that carbon and this carbon is now given to this one. Okay, 1, 2, 3, 4, 5, 6, 7. Yes. So these two carbon, sorry, these two carbon are now being replaced here. So we can say that A and C are isomers in that sense, since they have the same molecular formula and but different structure. So how they have the same molecular formula? Since they have same number of carbon atoms and they have only single bonds, so they are in the group alkanes, sorry, I mean alkanes, and and it is due to branching. And you can compare that A and C have the same molecular formula but different structure. Just these two carbon is been placed here. Okay, these two carbon has been placed here in C. That's it. The isomer of A is been created in C. Okay, that's it for today. But I have one thing to show you. Please don't go. Well fellas, this is the end of today's tutorial. Is there any part of this video that I have missed or you don't understand? If yes, then well fellas, this is the end of today's tutorial. Is there any part of this video that I have missed or you don't understand? If yes, then let me know in the comment section. Okay, ask question regarding this video tutorial. How was it? How do you feel about the video tutorial? And I know that you have a lot of questions to ask me. Please ask questions and let me know which problems you are facing, and please mention them in the comment section. Okay, and also here is the free courses only for you. You can click here to grab them. Full list of courses here. Please click here and please vote for this video tutorial. Let me know that whether it was favorable for you or not. Okay, thank you.